The most powerful computer chip in the world, at the time it launched, was sitting inside a phone. Not a server room, not a supercomputer, a phone you could hold in one hand. And the company that built it, they weren't even a chip company. For decades, the entire computing industry ran on one rule. Phones used efficient chips. Powerful computers used Intel. That gap was supposed to be permanent. The physics didn't lie. Small chips meant less power, less performance, less everything. But Apple didn't just close that gap. They crossed it, quietly, over 20 years. And by the time Intel realized what was happening, it was already too late. This is the story of how a music player, a refused phone call, and one secret architecture decision put Apple in control of an industry they were never supposed to dominate. To understand what Apple pulled off, you need to understand that not all chips think the same way. Every processor runs on instructions, tiny commands that tell it what to do. Add these numbers, move this data, store that file. The question was never whether to use instructions. The question was how many. Intel's approach, which powered nearly every desktop and laptop on the planet, was to keep adding more. More complex instructions, more capability, more everything. It worked. For a long time, it worked extremely well. But complexity has a cost: heat, power consumption, and physical space on the chip itself being eaten up by instructions that rarely got used. Meanwhile, a small British company called Acorn took the opposite approach in the early 1980s. Strip it down. Use only the instructions you actually need. Their project was called the Acorn RISC machine, ARM for short. The ARM chip was so efficient that when engineers first tested its power consumption, the reading came back as 0. They thought the equipment was broken. It wasn't. The chip was running on residual power alone. Power it was pulling from connected data lines, not even from a proper power supply. That's how little energy it needed. ARM chips ended up in Nokia phones, MP3 players, and eventually every smartphone ever made. They were everywhere, but always in low-end, low-power devices. Nobody serious thought they'd ever challenge Intel on raw performance. Apple was paying close attention. In 2005, Apple made a decision that looked like a defeat. Their longtime chip partner, PowerPC, was falling behind Intel on performance. So Apple switched. They signed a deal with Intel and moved their entire Mac lineup to x86 processors. But here's what most people missed. While signing that deal, Apple was already thinking about what came after it. They went to Intel with a proposal. Could Intel build the chip for a new mobile device Apple was working on? Intel's CEO at the time looked at the numbers, decided the revenue wasn't worth the engineering investment, and passed. He also didn't think the device would sell particularly well. That device was the iPhone. When the iPhone launched in 2007, it ran on an ARM chip. Not designed by Apple, not yet, but ARM-based. And it sold. It sold in numbers that reshaped the entire consumer electronics industry. Intel watched from the sidelines. By 2008, Apple wasn't just using ARM chips anymore. They licensed the ARM architecture directly, meaning they could now design their own chips from the ground up. They then quietly acquired a company called PA Semi, founded by engineers who specialized in building high-performance ARM processors. Most people reported it as a minor acquisition story. It was actually Apple assembling the team that would eventually make Intel irrelevant to their business. What happened next wasn't a single breakthrough. It was something harder to see and harder to stop. A decade of compounding improvement. Every year, Apple's iPhone chip got faster. Not slightly faster, dramatically faster. While Intel's desktop processors improved at a modest rate, Apple's mobile chips were improving at several times that pace. By 2012, Apple released their first fully custom-designed chip, codenamed Swift, inside the iPhone 5. It was twice as fast as what came before it. Striking. But it wasn't the moment that rattled the industry. That came in 2013. Apple put a 64-bit processor inside a phone, the iPhone 5S. At the time, ARM's own engineering teams hadn't finished their 64-bit design yet. Apple beat them by over a year. When Apple called it desktop-class architecture, most people assumed it was marketing language. It wasn't. It was a statement of intent, made years before they could fully back it up. By 2019, Apple's iPad was outperforming Intel's MacBook Pro from the previous year. A tablet, beating a laptop, on raw processing benchmarks. Intel's performance advantage, the one that had defined the PC industry for 30 years, was disappearing. In late 2020, Apple announced they were leaving Intel entirely. The chip they introduced was called the M1. Built on the same ARM foundation as the iPhone chips, but redesigned from scratch for laptops and desktops. More transistors, more memory bandwidth, more everything. The reviews that came back didn't read like normal tech coverage. They read like people trying to explain something they hadn't expected to be true. Of long-term decisions that most companies are structurally unable to make. They absorbed short-term costs, the expense of acquiring PA Semi, the years of chip development, the risk of breaking compatibility with decades of Intel software, because they were building towards something that wouldn't pay off for a decade. Intel, by contrast, was optimizing for what already worked. Their chips were profitable. Their customers were happy. The incentive to disrupt themselves simply wasn't there. This is a pattern that shows up across business history. The company that defines an industry rarely destroys its own position to build the next one. It's almost always an outsider, or in Apple's case, a customer who decided to become their own supplier. Apple started this story as a company that couldn't even build its own chips. They bought their processors from Motorola, then IBM, then Intel. At every stage, they were dependent on someone else's decisions, someone else's roadmap, someone else's priorities. The moment they decided to change that, quietly, without announcing a grand strategy, everything else followed. Intel didn't lose because Apple was smarter. Intel lost because Apple was patient. That one decision to pass on the iPhone set off a chain of events that took 15 years to fully play out. And by the time the consequences arrived, there was nothing Intel could do to reverse them. So here's the question worth sitting with. In your own work or your own business, are you playing for this quarter or for the next decade? The companies that win the long game rarely look like winners at the start. If stories like this are what you're here for, subscribe to Ledger and Logic. There are more of them.